Welcome to this interactive study guide on states of matter, a key topic in AQA GCSE Physics. In this video, we'll break down the particle model of solids, liquids, and gases, explore energy changes during melting and boiling, and tackle density calculations. By the end, you'll have the tools to ace exam questions on heating curves and required practicals. Let's get started. Let's map out the particle model. In solids, particles are tightly packed in a regular lattice and vibrate about fixed positions, giving solids a fixed shape and volume. In liquids, particles are close but irregularly arranged, allowing them to flow and take the shape of their container while maintaining a fixed volume. In gases, particles are far apart and move randomly at high speeds, so gases expand to fill any container. Now let's dive into our core study notes. Internal energy is the sum of kinetic and potential energy of all particles. When a substance melts or boils, energy is used to overcome forces between particles, increasing potential energy while temperature stays constant. This energy is called specific latent heat, calculated using E equals mL. Remember, during freezing or condensing, the same amount of energy is released. Let's walk through a heating curve. Starting as a solid, as we add energy, the temperature rises because particles gain kinetic energy. At the melting point, the temperature plateaus. Energy is now used to overcome forces between particles, increasing potential energy. Once fully melted, the liquid's temperature rises again until the boiling point, where another plateau occurs as particles gain enough energy to become a gas. After boiling, the gas temperature rises. Let's work through a typical density calculation. First, convert mass from grams to kilograms. 500 grams is 0.5 kilograms. Then convert volume from cubic centimeters to cubic meters. 200 cubic centimeters is 0.0002 cubic meters. Now apply the formula, density equals mass divided by volume, so 0.5 divided by 0.0002 gives 2,500 kilograms per cubic meter. Always check your units and show you're working for full marks. Watch out for these common mistakes. First, don't mix up melting and boiling plateaus on heating curves. Second, always convert units before calculating density. Third, when explaining plateaus, explicitly say that temperature remains constant because the energy is used to change the state, not to increase kinetic energy. Examiners love that phrase. To wrap up, remember the particle model for each state. Internal energy combines kinetic and potential energy. Use E equals mL for state changes without temperature change. Density is mass over volume, with careful unit conversion. And on heating curves, plateaus indicate state changes where temperature stays constant. Apply these concepts to exam questions, and you'll secure top marks. Thanks for watching.